Index numbers are a convenient way to make comparisons between numbers that may have been measured at different times or in different places. In this video, let's take a look at the Consumer Price Index, and we'll use that to look at an example involving tuition and fees. So as you learned in your reading, an index number can be found by comparing some sort of a value to a particular reference value and then multiplying by 100 to generate a percentage. Now the reference value is arbitrary, so we can choose what that would be, or you can look at an index and see which number was chosen as the reference value. It's also possible to create a different index just by changing that reference value. So let's do an example. Let's say we want to make a price index for 3 different prices, $3, $5, and $6. One thing we might do is find the average of those prices and then use that as our reference value. Right? So if we average those 3, we will get $4.67. Alright, so then in the price index we need to indicate what the reference value is. So we can do that by stating that the average is equal to 100%. And then let's go through the steps for finding the index number for each of these prices. Alright, so we just need to take each value and compare it to our average and then multiply by 100 to get a percent. Alright, so if we take the first one, $3, then we take $3 and we compare that to $4.67 and multiply by 100. And I think what I'll do is actually, let me put 0 cents on these prices, and then we have 3 significant digits in each case, right? And that way, when we are calculating the index number, now everything has 3 significant digits, because we are working with exactly 100. And then in that case we can give an index number that's also 3 significant figures. Okay, so if you do that first calculation, you'll end up with 64.2. And of course we drop the percent sign and just write that as an index number. So now for the next one, for $5, you'll notice that that price is a little bit above average. All right, so you should be expecting to see an index number that's a little bit above 100. All right, so we compare that value, $5 to $4.67, do the same thing, and multiply by 100, and then that gives 107.1. All right, and then let's do $6 as well. And that index number is 128.5. Okay, so what index number would you expect to see for the average? All right, well, if we follow this formula, when the value is the same as the reference value, right, then when we divide with that fraction, you're just going to get 1, and then multiplying by 100 would give you an index number of 100. All right, so that's an observation about indexes in general. These percents, all right, these are actually percents of, rather than percents more than or less than. So if you think back to the section where we talked about of versus more than or less than, right, then the percents of indicates a multiplication, whereas more than or less than would indicate addition or subtraction. All right, so when you see the number 100 in the price index, that means that that corresponding price is 100% of the reference value. Okay, because notice it wouldn't be 100% more than itself, so that's the clue that this is a percent of. All right, so then that means when you see this 64.2, we can read that as indicating that the price $3 is about 64% of the reference price. Okay, not 64% more than or not 64% less than. All right, what about 128.5? That means that $6 is 128.5% of the reference value. Or if you wanted to talk about a percent more than, we could say that it's 28.5% more than. So that's going to come in handy when we start talking about inflation. Now I want to show you one shortcut for these formulas. There are some boxes throughout your reading with different ways to calculate index numbers or price indexes or calculate prices adjusted for inflation. All of these can be summarized with proportions. So if you do like the method that's given in your reading, go ahead and just keep using that if it makes sense to you. But if you're kind of getting lost on if the value or the reference value should be in the numerator of the fraction, and if you just can't remember which piece goes where, you may like a proportion as an easy way to keep track of this. All right, so if you take this formula that's given, now notice on the right-hand side we have times 100. So I can move that to the left side of the equation by dividing by 100, and then you would get index number divided by 100 equals value divided by reference value. Right, and then this 100 would be gone. All right, so this is a proportion. It's just two fractions that are equal to each other. And this makes sense if you realize that we're just talking about percentages, which are fractions, and we're making comparisons. That's what indexes do. So we're just comparing fractions to each other. So then as far as keeping track of what goes where, there's actually some flexibility with proportions. So the only thing you really need to do is sort of match things up. So whatever your, if you put value over reference value, well then the index number that goes here is the one that matches the value that you're talking about. So if we're looking at like a 2000 from the year 2005 price, then you would put the 2005 index number over here. The reference value always has an index number of 100, so those two kind of always go together. But proportions are flexible. You can kind of mix this around. So you may remember if you've learned proportions before, you can flip the two fractions upside down. So there's nothing wrong with doing 100 over a certain index number is equal to the reference value over the value. All right. You can write your proportions kind of side to side instead of up and down. Right. So if you wanted, you could do a value over its index number. So like a 2005 price over the 2005 index number, and then you can do some sort of whatever your reference value is over its index number, which is 100. And if you're comparing year to year, maybe you're not using the reference value, but this would still work. Okay, so you could do like a 2005 price compared to a 2008 price, and then you would just compare the 2005 index number to the 2008 index number. All right, so those are some things that you can do with this. So let's use one of the index tables from your reading and try out a sample problem using this proportion method. And again, if the method that's described in the reading works for you, you can skip this part and just keep doing what works. But this is just an alternate method. All right, so let's look at example 2, part A. Suppose it cost $16 to fill your gas tank in 1985. How much did it cost to buy the same amount of gas in 2015? All right, so we have two different years. We have the price in 1985, and we're looking for the price in 2015. All right, so just remember, we're not looking for like the stated price in 2015. What we're doing is trying to adjust for inflation, and we want to convert this $16 the $16 price. We want to convert that like to $2015. All right, so let's use the price index and let's find the index numbers for 1985, which happens to be the reference value, and then the number for 2015 is 210. All right, so let's make a proportion so we can compare. Now, one thing that's nice is to have the thing that's unknown in the numerator of the fraction. All right, so let's compare the cost of gas in 2015, right, to the cost of gas in 1985, right, and then we'll compare the two price index numbers, right? So the 1985 number is 100, and the 2015 number is 210. Okay, so you may remember for proportions, to solve these, you would cross multiply, right? But there is a shortcut as well. In order to just solve for this missing price, right now it's divided by 16, so I can also just multiply by 16 to get that by itself. Right, so if you multiply each side of the equation by 16, then that will solve for this cost. Right, and then here's the calculation we need to carry out, which is 100 divided by 210 times 16. And I just realized I made a mistake in setting this up. If you carry out this calculation, I think you'll see it too. This gives a price of $7.62, which shouldn't sound right because I think you should be expecting to see a higher cost because of inflation. Right, so if that happens, just go back and double check. And when I wrote the second fraction, I mixed up which price was which. So the $16 is the 1985 price, right? So that means that the 1985 index number should go in the denominator, and the 2015 amount that's the one we're solving for. So in the numerator. So the index number for 2015 should also go in the numerator. Okay, so now if you carry out that calculation, you should get a cost that's higher than 16. Okay, and that should be $33.60. Okay, let's do the next one. Suppose it cost $20 to fill your tank in 2005. How much did it cost to buy the same amount of gas in 1965? Okay, so let's compare the index numbers. So for 1965, it's 25.8, right? And for 2005, it is 192.5. Okay, so I'm actually going to write the years next to these just so I don't make the same mistake again. All right, so 25.8, that's 1965, and 192.5, that's 2005. So then on the right, let's write the prices and compare those. So it cost $20 to fill the gas tank in 2005, right? And then it's unknown how much it cost in 1965. All right, you can use an X here if you like with variables. All right, and then let's do one example with cross multiplying in case you need to remember how to do that. All right, so using that method, you would multiply 20 times 25.8, and you would multiply 192.5 times X. All right, so you're going to get 192.5 X equals 516. And then to solve for the missing price, you divide both sides of the equation by 192.5. All right, and you should get $2.68. All right, so in this case, cross multiplying does take one extra step, but a lot of people remember that pretty easily as a method. So it will work all the time to solve proportions. But in this case, if we back up just a little bit, you could have also just multiplied each side of the equation by 20, right? And then that would give you the same thing.